All right, hello everybody. This is a video key for your 2B.1-2B.2 knowledge check. Hopefully at some point you have read all this information at the top, which summarizes everything we've done. I've gone through and shown some of this work already, or I've done some of the work ahead of time, but I'll explain where everything came from. All right, so on the first problem, this is just the parent function, which at this point you should just know that the graph looks the way it does. So we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And the graph looks like this. And then with domain and range, it's actually the same for both here, but remember domain it's always going to start negative infinity until you get to a vertical asymptote, and then you stop at the vertical asymptote, and then you got to start on the other side of the vertical asymptote, so start right back up at 0, and then go forever this way. And if there's two vertical asymptotes, that'll happen later on. I'll show you how that changes the way this looks. For range, this one's negative infinity because it's going down forever this way, and then it comes up until y equals 0. The parent function skips over y equals 0 and then continues to go up forever. And so this notation here is showing us skipping over a value of 0. All right, on number 2, this is just shifts, translations of the parent function. This, you can either think of this as two ways. We know from earlier stuff that we've learned that a +2 actually makes a graph go left 2, and this makes it go down 3. But really for these functions, you're trying to figure out what you can plug in for x that would make the bottom equal 0, because then those are values that we're not allowed to equal. And so either case, that's x equals -2, which is why we have a vertical asymptote at -2 right there. This shifts it down 3, so we have a horizontal asymptote at y equals -3. And then our graph looks just like the parent function, like so. The one thing we didn't do is we should find this y-intercept right here. So remember, a y-intercept is when you plug in 0 for x. So our y-intercept, we're plugging in 0 for x. So it's 1 over 0 plus 2 minus 3, which is 1/2 minus 3, which is -2.5. And so all we have to do is really label that on here at -2.5 or -5/2, however you want to write it. So always find your y-intercept. The first graph doesn't have a y-intercept, so we couldn't find that. All right, so our domain then, again, it's just going to be negative infinity until our vertical asymptote, and then vertical asymptote to positive infinity. So that's just negative infinity to 0, union 0 to infinity. Same thing for the range, negative infinity to -3, union -3 to infinity. Remember that you actually can cross a horizontal asymptote, but it doesn't happen on the parent function, and it doesn't happen on just shifts of the parent function. If we were able to cross this, we would somehow have to figure that out, which is not really what we're getting into for these graphs. But if it did cross it like that, then that would change the range because now we did equal a value of -3. But again, that would not happen on the parent function or just simple shifts of the parent function. It would not cross this horizontal asymptote. All right, jumping down to number 3. Oh, we should be finding x-intercepts also. But we're not. I will specifically ask it on problems where I want you to find it. I'm not going to have you find it on this one, even though there is one. It just, the algebra required is not what I want to get into right now for those problems. Number 3. So this one's already in factored form. Any ones that weren't, I've gone through and factored already. But you want to factor the denominator and numerator when possible. So you can find what makes the bottom equal 0, which you get 2 and -4. And so that is why I've already drawn our vertical asymptotes there. And now at this point, we have learned that when the degree of your numerator, this actually has a degree of 0, and our denominator has a degree of 2 because it's a quadratic if you multiply it together. When the degree on top is smaller, you always get a horizontal asymptote of y equals 0. And so we see that here. I just realized this one's drawn in the wrong place because I never moved it after I copied and pasted. All right, so now There are no x-intercepts because our numerator never equals 0 because it's just the number 1. And so now we got to figure out where the graph is located. Since it doesn't cross the x-axis, it's either here or here, and here or here, and then it has to be a U-shape down here, because if it's an S shape, it would have to cross the y-axis. I mean the x-axis, which it can't. So let's find our y-intercept again. So our y-intercept is when x equals 0. So that's 1 over 0 minus 2 times 0 plus 4, which is just negative 1/8. And so now we know our y-intercept right here of negative 1/8, and that tells us that a piece of this graph has to be down here like this in order to cross through the y-intercept. We don't know exactly how high or low it goes, and that doesn't matter for what we're doing anyways. And now we got to figure out the other two pieces. Is it up here or down here, or up here or down here? And this is where we can analyze, plugging in a number close to 2, but bigger than 2, like 2.1. And if you plug in 2.1 right here, you're going to get a positive number from this bubble, and you get a positive number from this bubble. And so when you multiply them together, you're going to get a positive number overall that we know is going to get bigger and bigger and bigger forever, because this number gets really small, and 1 over really small is really big. And so now we know we have a portion of the graph up here. And so it's got to always trend towards the asymptotes, so we know it's going to flatten out this way and go further that way. And then let's pick a number on this side of negative 4, like negative 5. Well, I'd get a negative, or negative 4.1, sorry. I would get a negative here, and I get a negative here, which multiplied together results in a positive. And so once again, as we approach negative 4 from this side, we're going to positive infinity. And so that's why that graph looks like that. Okay, coming over to number 4, again, no x-intercept, because our numerator is not 0 and never can be. I've drawn the vertical asymptotes at negative 10 and negative 4 already. And since our degree on top is smaller than the degree on the bottom, we have a horizontal asymptote of y equals 0. So this one's very much like the last problem. Our y-intercept, plug in 0 for x. It's actually easier to go to the non-factored form, because when you plug in 0, these are just gone, and you just get 1 over 40. So you have a y-intercept of 1 over 40, which is right here somewhere. Sorry, it's positive 1 over 40. So it's up here. So 1/40. And then we can draw the graph through that point, not crossing the x-axis and following the asymptotes. So it looks something like that. I'm going to undo that for a second and move this. So this piece has to look something like this. And then we got to find the middle part. So again, it doesn't cross the x-axis, so it's either an upside down U or a right side up U shape. So pick a number on this side of negative 4 or on this side of negative 10. So I'll do negative 4.1. Negative 4.1 will give me a negative here and a positive there, so it's negative overall. So now we know it goes down as it approaches negative 4. And since it can't cross the x-axis, it's got to turn around somewhere and then look like that. And so this piece looks something like this. Again, we don't know exactly how high or low that goes. I got to go back to number 3 and tell you the domain, but we'll do that in a second. And then we got to do the same thing over here. Is it here or is it here? And so let's pick like negative 10.1. That'll give me a negative number here and a negative number here, which is positive overall. And so it's going to look something like this, because it's going to go up when we get that positive result. Okay, our domain for this one is going to be done similar to number 3, actually. My vertical asymptote's in the way, though. Get rid of some of that. All right, so our domain, again, it's just going to go negative infinity. So it's over here forever until we get to this vertical asymptote, which is -10. And then you start right back up at -10 and go until the next vertical asymptote, which is -4. So union -10 to -4. And then we have to do that union from start right back up at -4 and go this way. And now that goes forever. So -4 to infinity. Oh, I didn't want to move the vertical asymptote. Oh. All right. We'll just squeeze this in here. So -4 to infinity, like that. Okay, coming back over here to number 3. We'll just write the domain over here. So this is -infinity to -4, union -4 to 2, union 2 to infinity. So just like number 4. So the domain's done in the same way all the time. So once you get it, it's pretty easy because you kind of do the same thing all the time. It's just different numbers that you're plugging in into these spots, like here, 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 and there. All right, on number 5, let's start by finding our y-intercept. So if I plug in 0 for x, those are gone. You get -4 over 30. So we have a y-intercept right here of -4 over 30. X-intercept now comes from when the top is 0, which for the first time we're going to have one, and that is at x equals 4. So x equals 4 is right here somewhere, roughly. Okay, so that tells us now that this graph on over here, it can't come from down here and go up because it would have to cross through the x-axis twice, which it doesn't, which means it has to come from up here, down, get to the y-intercept, then it's got to curve back towards the horizontal asymptote because that's how graphs behave for their end behaviors at horizontal asymptotes. So this graph has to come down like this, cross through right here, turn around to cross through the y-intercept, and then go on forever to the left. And now we got to figure out this part. This part, again, cannot be an S-curve because there's no x-intercept in here, because the only x-intercept we already found right there. So we got to do the same analysis as before. Let's pick like 5.99 and see what happens as we go towards 6. 5.99 plugged into this gets me a positive. This gets me a negative. So therefore the graph goes down towards -infinity as we get closer to 6. And since we already know it's got to be a U shape, it's got to look something like that. And then out here, same analysis. Let's pick like 6.1. And you get a positive, positive. So this side goes up forever. And it's got to flatten out towards its horizontal asymptote to the right. Our domain. Sorry, I didn't mention the vertical asymptotes on here, but it comes from here. We have x equals 5, x equals 6. So our domain is -infinity to your first vertical asymptote 5, union vertical asymptote to vertical asymptote, union vertical asymptote to forever. All right, number 6. Again, I've already factored it, so I found the vertical asymptotes here and here. Our degree, I didn't mention this on the last problem either. Our degree on top is 1, and it's 2 on the bottom. Same with this problem. Degree on top of 1, degree on bottom of 2. So when the degree on top is smaller, you always get a horizontal asymptote of y equals 0. So that's why we have that on both of these. So now let's find our x-intercept, which is from when the top equals 0, you get x equals 3. So now x equals 3. And so this one is in between the vertical asymptotes. And so what that means is we have an x-intercept in here, and so now we had to have an S-curve in order to pass through. So it's got to be one of those two things. And the y-intercept, if it's here, then it's going to look like this. If the y-intercept's up here, then it's going to have to look like that. So let's find the y-intercept, which plug in 0 for all these x's, and you get -3 over -16, so 3/16. So you get 3/16. right there. And so now we know the graph has to go like this in order to pass through both of those points. So we can draw that portion of the graph. It's going to go down like this, through the y-intercept, through the x-intercept, and like that forever. And now we just have to determine what happens on the other sides of the vertical asymptotes. So as we approach -2, like -2.01, so you're going to get a negative and a negative, which are positive overall. Oh, but you got to check the top too. So negative, negative, and then negative again. So you have 3 negatives, which actually make it negative. So this piece has to go like this. And this is where you can use this table if it helps you. So that's up to you if you want to use that. And then we're on this side of 8, so you're plugging in like 8.1. Plugging in 8.1 will get you a positive, positive, positive. So you get all positives. If this part is confusing at all, just use a calculator and actually plug in 8.1 and see what you get. You're certainly allowed to do that. So that's what that graph looks like. All right, coming down to 7, I've already factored the numerator and denominator for us. Labeled my vertical asymptotes, which come from the bottom. My x-intercepts now come, we're going to have 2 of them. We have one at x equals 9, which is out here somewhere. And we have one at x equals -5 from setting the top equal to 0. So you just set each bubble on top equal to 0. So we have -5. I'll just put that right here, let's say. All right, so now, unfortunately, this is not enough information to know what the graph does over here, because it could go like this. We don't know if it crosses the horizontal asymptote or not. So we're still going to have to go through our same analysis. What we do know is in here, since there's no x-intercept, it's got to be a U-shape one way or the other. Not an S-curve, because there's no x-intercept in the middle. Now we can find the y-intercept, though, which is -45/21, because you plug in 0 for x, those are all gone. So you get -45/21, which is going to be down here somewhere. So now that does shape this part for us. It's got to go like that, because it has to pass through both of these points. So it comes like this, through the y-intercept, through the x-intercept, and then flatten out towards the horizontal asymptotes. Our middle part, let's pick like 3.1. Now you got 4 bubbles though, so 3.1, I'll write this down. So you plug in 3.1, you get a negative, positive, negative, positive. So we have 2 negatives overall, which makes it a positive overall. So our middle piece, as we approached 3, goes up forever. And then we already know it's got to be a U-shape because it doesn't cross the x-axis in there, because we would have found it if it did. And so that part looks like that. And then we do cross through this x-intercept here, but it could theoretically do this. So we got to check, pick a number bigger than 7, but slightly bigger than 7, like 7.1. And you get a negative, positive, positive, and positive. So it's negative overall, because you only had 1 negative there. So that tells us it does go down forever towards 7, and then has to turn like this and approach its horizontal asymptote out there. Our horizontal asymptote, by the way, is y equals 1, because for the first time, our degrees on top and bottom are the same. And so you take the leading coefficients, which are both 1, and you divide them by each other. So it's just 1 over 1. The same thing is happening on number 8. But remember, if I put like a 4 here, oops. If I put a 4 here and a 7 here, then our horizontal asymptote would be y equals 4/7. Okay, so if that happens, that's how you get something other than y equals 1. It just comes from your leading coefficients. Well, we got to go back to 6 real quick and do domain and range. So domain, same as it's been for all the other problems. You go -infinity until the first vertical asymptote, -2. Union, vertical asymptote again to the next vertical asymptote, oops, which is supposed to be 8. And then union, vertical asymptote to forever. Our range on this one we're able to do because this middle section goes up and down forever. So our range is simply negative infinity to infinity. Okay, notice I don't ask for range on this one. That is because we have a U shape in here and we don't know how to determine how low that goes. But our domain is negative infinity to our first vertical asymptote, which is 3, union vertical asymptote to vertical asymptote, union vertical asymptote to infinity. So hopefully you're catching on domain. These are some of the easiest domains we do because they're pretty much written the same way every time, just based on these numbers here. All right, jumping over to number 8, let's find our x-intercepts, which come from when the top is 0. So you get negative 6 and positive 2. So negative 6 is over here somewhere. And positive 2 is going to be between our vertical asymptotes. So we have negative 6 here and positive 2. Our y-intercept, plug in 0 for x, and those are gone. You just get negative 12 over negative 11, so 12 elevenths, which is more than 1, so it's up here. It's got to be above your horizontal asymptote. So that's 12 elevenths. And so now we know what the middle piece looks like. It's got to approach our vertical asymptote, cross through our y-intercept, cross through our x-intercept, and continue going down forever. And so let's draw that like so. Okay, over here we have an x-intercept at negative 6. Again, in theory, it could do something like this. Well, actually, no, it can't. It can't do this and then turn around because it would have to have 2 x-intercepts. And we're not seeing any graphs where it's going to bounce off the x-intercept, so now we know that it has to do this. So that piece has to look like that. And then let's pick a number bigger than 11, like 11.1. Come up here, you're going to get positive, 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 positive. It's all positive, which means the result is positive, so the final piece is going to be up there. We also know that without doing the picking a number and checking, because it can't be down here, because if it was down here, it would have to cross through the x-axis, and we already found all the x-intercepts, and there wasn't one over here, so you know it has to be up there. So there's a more logical way to do it than like picking numbers. Okay, our domain is negative infinity to negative 1, union negative 1 to 11, union 11 to infinity. Our range, it goes up and down forever, so it's just negative infinity to infinity. All right, there you have it. Hopefully that's helpful. Good luck on your test.